All right, so today, Mr. Kolaski and whoever else is following along at home, we're going to talk about climate and weather. In our last lesson, we talked about external forces and internal forces shaping the earth. Today, we're going to spend a lot more time on climate and weather. So it's going to be kind of a long one. Today, it's probably going to end up being about 20 minutes or so, but just bear with me as we talk about, first of all, what is climate? How do we describe climate when we're talking about it? And what are the elements, or what are the 5 things that make up climate? Okay? So first of all, we've got to answer the question, what is climate? Okay, what is it like outside today? I want you to think about what was it like outside this time last year. Okay, and what I want you to think about is, or rather, climate is the average weather conditions over a period of time, usually a year. So you're going to look at a whole year, and you're going to take those average weather conditions, and we'll talk about what specifically that means in a second. So if climate is the average weather conditions, then what then is weather? Well, weather is the condition of the atmosphere at a particular place and time. So basically, weather is what's going on right now, and climate is what is it usually like in an area. And this can vary quite greatly and can vary really widely depending on where you are in the world. So when we describe climate, what are the characteristics that we use to describe climate in almost all situations? What are the things that we use to describe it? Well, first of all, we're going to talk about temperature. Is a place hot or cold? Okay. This means, are we looking at, is the average temperature of a place over a given time, over a year, 75 degrees Fahrenheit, or is it -4? Or is it 32 degrees Fahrenheit, which is right at freezing? So we're describing a place and whether or not it's hot or cold, and we're giving that number in average temperature in a year. Second thing we're going to look at is the precipitation. And we're going to look at how much precipitation an area gets in a year, and we're also going to look at what types. Remember, precipitation is simply put rain, or water rather, falling out of the sky. It takes several different forms. Rain, snow, sleet, hail are all different forms of precipitation. And when we look at precipitation, we're going to look at how much falls in an area over a given time. And usually, again, that's a year. That's what we talk about when we describe climate. And lastly but not leastly, we're going to talk about, and we're going to look at whether or not the place has seasons. And what we're talking about when we have seasons are, do they have all the seasons like us, or all the ones we think about, summer, winter, fall, and spring? Or do they have a hot season and a cold season? Do they have a wet season and a dry season? Or do they have no seasons? Is it hot all the time? Is it cold all the time? What seasons is it exactly that they have? So if that's climate, and that's what weather is, and those are the characteristics of climate, what things make up climate? What things dictate climate? Okay, and there are 5 things that we're going to talk about. The first thing that we're going to talk about, and arguably the most important influence or element of climate, is latitude. The way I want you to think about it is this. Where is a place in relation to the equator? That's what latitude means. Based on the equator, where are we? And the way to think about it is, the colder the climate, as latitude increases, the colder the climate, or the further away from the equator you get, the higher the latitude, the colder the climate gets, or the cooler the climate gets. So what I want you to do, if you're keeping track at home, which Tyler, you should be, what I want you to do is I want you to take, and I want you to draw a circle just like this in your notebook. Take and fold that page just like I showed you. You're going to divide it in half. Again, this is on page 23 in your notebook. You're going to divide it in half. You're going to put a circle here and a triangle on one side. On the circle, I want you to draw the lines of latitude, and I want you to label them as they are there. And you're going to also label them mid-latitude, high-latitude, low-latitude climate. And you're going to take a colored pencil or something, and here's what you're going to do. You're simply going to write down what the latitudes are, or the climates are. At low latitudes, tropical, we've got tropical wet, or sometimes known as tropical savanna climate. Or, I'm sorry, tropical wet and dry. And you also have tropical wet or rainforest climate. So you've got those two climates at the lower latitudes. At the higher latitudes, there at your polar zones, you have subarctic taiga. Subarctic taiga exists right below the Arctic Circle, and it's made up of coniferous trees, big evergreen trees, like you would find in Canada or in Russia and Siberia. You also have an ice cap climate, which is at the very poles. Okay, that's a polar climate right here or right here, where it's just ice. And last but not least, the last polar climate that we've got is tundra or subpolar. So these exist at the high latitude. Tundra exists just south of the South Pole, and it's mostly made up of low-lying grasses and shrubs, and it's called subpolar because it exists right below the poles. In the mid-latitudes, you've got four main climates. Humid continental, which I always describe as the worst of the climates because you get all the hot and all the cold, all the hot in the summer, all the cold in the winter. But humid means rainy, continental means the interior of continent. And then you've got humid subtropical, which means just outside of the tropics, which is what we technically live in, a humid subtropical zone, because we are outside the tropics and we have a fair amount of rain. Next, we've got Mediterranean climate, which is a dry climate with cool, dry winters, cool, wet winters and warm, dry summers. Exists mostly around the Mediterranean. And lastly, we've got marine west coast climate as well. So those are the climate zones as they exist at the different climates. And now there are a couple of climates that exist at any latitude that we're going to talk about. So two climates that exist at any latitude, regardless of where they are arid or desert climate. Arid or desert climate gets less than 10 inches of rain a year. It can be either hot or cold. Don't stick in your brain that deserts are always hot. They can also be very cold. Sometimes deserts can get very cold at night, like the Gobi or the Tamaulipan Desert in China can both get cold at night. They have very little vegetation. Cactus is an example of a vegetation that grows in those climates. And last but not least, it's not just sand. Again, some arid or desert climates exist and are dry. In fact, ice-capped climates are usually also considered desert climates because of the limited amount of rain they get or precipitation they get a year. On the edges of deserts, you get what's called a semi-arid or sort of dry steppe climate. Steppe climates are really common on the edges of deserts or the borders of deserts. The North American steppe is the Great Plains. The Great Plains don't exactly exist on the edge of a desert, but they do exist in what's called the rain shadow, and we'll talk about that in just a second. Okay, they're primarily made up of grasslands. They receive 10 to 20 inches of precipitation a year, and again, they can be either hot or cold. The African savanna is a sort of a steppe climate. Central Asia is found in is a steppe climate. Steppe climate in Central Asia, Kazakhstan, Mongolia, and even far western China is considered a steppe climate. Next element of, or next aspect of climate or influence on climate is called mountains. Okay, mountains have the same influence on climate that latitude does. Mountains have the same influence on climate that mountain does. So this is a highland or a mountain climate, and altitude has the same impact that latitude does. So in a highland climate or altitude-based climate, temperature and vegetation both depend on elevation. Okay, and nextly, there are no trees above the tree line. So if you got two bullets. Okay, the last bullet on your notes pages, here's what they say. It's as the elevation increases, the colder the climate. As the elevation increases, the colder the climate. Or another way to phrase it is, the higher the elevation, the colder the climate, just like latitude. This is known, this concept is known as vertical zonation. Vertical zonation is the idea that the further up a mountain you go, the colder the climate gets. And what I want you to do now in your notes is I want you to take it on this triangle. All I want you to do is I want you to underline, okay, I want you to draw these four lines. Draw a line here, and you're going to label it 2,500 feet. That's called Tierra Caliente, and that is basically rainforest hot climate. Caliente means heat. Okay, the next line you're going to label it 6,000 feet. This is called Tierra Templada. Tierra Templada is the zone in which most people in Central America live. Whoops, I got to go back. It's the zone in which most people in Central America live, and most people in Latin America live as well. Up next, you've got Tierra Fria, goes up to 12,000 feet. And there's a line at 12,000 feet, and that's called the tree line. No trees grow above it. Okay, if you've ever been to the Rockies, you've ever seen the really tall mountains in the Rockies or the European Alps, you've seen that tree line where it's basically a straight line where trees don't grow above. The next one, I want to change the name just a little bit, and I'm going to mark this as not Tierra Helada, and I'm going to do that on here too. So Tierra Helada and Tierra Nevada are gone there. Okay, and I'm going to label this one Puna. P-U-N-A. Okay, so Tierra Puna is the next line. Tierra Puna exists from 12,000 to 15,000 feet up in the air, and it is very similar to the tundra climate. It's cold, barren, and can really only be used for grazing sheep, llamas, or alpacas. Now, Tierra Nevada, we're not going to call Tierra Nevada. We're going to call this top one Tierra Helada. The Spanish word for ice cream or ice is helado. So we're going to call this Tierra Helada. You notice it's really hard for me to write on there with that. Okay, so those are the climates and those are the vertical zones that you get there. And the idea that I want you to get out of this is that as the equator increases, the further away from the equator you get, the colder the climate. Well, the same idea exists here. The further up a mountain you go, the colder the climate, even if it's on the equator. All right, the next thing we're going to talk about are the influence that winds have on climate. So this is the next influence or factor that it determines or helps you determine what a climate is in an area. And it's the regional prevailing winds can influence the climate of an area to make it the climate colder or warmer than it should be based on the latitude. The regional prevailing winds can influence the climate to make it colder or warmer than it should be based on the latitude. So again, you're going to draw another circle, but this time it's going to be a small circle here or here in your notes, somewhere on the outside on the notebook paper itself. And what you're going to draw is a circle that looks like this. Okay, and you're going to do some reading in your textbook about it, so this doesn't have to be perfect. But draw a line in the middle, draw a line at approximately 30 degrees, draw another line up top. Now what I want you to do is I want you to draw these lines right here. These lines coming down are called trade winds, and label them. They're called trade winds. They blow from the northeast here to the west, and these blow from the southeast here into the west. And they swirl a little bit because of something called the Coriolis effect, which you should be reading about or should have already read about in your textbook or going to soon. Okay. The next thing is mid-latitude and high latitude. At the middle latitudes, you've got what are called westerlies, and the westerlies, just draw them, are blowing in that direction. They're blowing from the west to the east. The information or what you need to know is that winds are always named for the direction from that they come from, not the direction that they're going. And last but not least, we've got polar easterlies. Polar easterlies, again, blow from the east and to the west. That's why they're called easterlies. Okay, so those are the latitude, and those are the wind belts. Those are regional prevailing winds that exist at different latitudes. Okay, so what I'm going to do now is I'm going to do this real quick, see if I can erase. Nope, apparently I can't erase these real easily, but that's okay. So what we're going to talk about next is the next thing we're going to talk about are what are the effect that water has on this, and especially in combined with wind, that wind and water play a tremendous role on our environment. So being near a body of water plays a tremendous impact. Water brings rain or some sort of precipitation. Okay, so when water evaporates, it goes up into the air, and the winds move it around. That's when clouds are formed, etc. And wind brings water in the form of precipitation. The kind of precipitation depends entirely on the body of water. If the body of water is cold, like the Great Lakes, you get what's called lake effect snow. It's dumped on Buffalo, New York. If it's warm, like the Atlantic Ocean or the Pacific, then you just get rain, and it can influence the climate. Okay? An example of this, B, Roman numeral little I. An example of this is Western Europe. Western Europe is an example of this. The climate of Western Europe is called marine west coast because westerly prevailing winds right here blow over warm ocean current called the North Atlantic Drift. Highlight North Atlantic Drift in your notes. Blows over the warm North Atlantic Drift, and it makes the climate of England and Northern Europe very comfortable compared to what it normally is what it should be based on its latitude. Okay, and also the northwestern U.S. has the same climate, marine west coast climate, which is warmer than it should be because of those regional prevailing winds. Next, we've got a concept that landforms have a tremendous impact on climate and weather. So we've got 5 things that influence our climate. 1, latitude, 2, altitude, 3, winds, 4, water, and lastly, we've got landforms or physical geography of an area. Another example, and this is how they work together, another example of regional prevailing winds and body of water playing a role on climate and land now is when regional prevailing winds and water hit a mountain range. The mountains block precipitation from crossing that mountain range, and they keep the rain to one side. This is called the rain shadow or the orographic effect. So what I want you to do in your notes, in the blank space that's down here, what I want you to do is I want you to draw this diagram. Okay, and so what you're going to see, and I'm going to point it out. Oh, there's an eraser. I can use it now. Okay, what I'm going to do is I'm going to point out these things to you, and I want you to draw the diagram as I point it out. In class, we did it all together, and made a lot of sense, and guys picked it up really easily. This is not something that's real complicated, okay, but you do have to pay a little bit of attention. All right, so let's go back to the area. So now what happens is over an ocean, water evaporates as it heats up. Everybody knows that. Then it forms a cloud. All right, clouds form. Regional prevailing winds push those clouds over to a mountain. Okay, they move the mountain. Well, clouds are heavy. They sink. It's like carrying a heavy water cooler full of stuff. When you put it in your car after your game, sporting game or something, you dump it out. Well, just like that, you dump out the water out of the bucket. So you dump out the water out of the bucket, and guess what? It goes down. So just like this, the water goes down on the mountain. Because in order to go over to the other side of the mountain, the cloud has to get rid of its water. This, on this side of the mountain, by the way, it's called the water cycle. The evaporation, movement, and raining or falling of water and seeping into the ground is called the water cycle. If you've had earth science, you know that. Okay? Well, as the cloud continues, it's now lost most of its water, if not all of it, and this dry air goes over. Okay? Creating a dry desert or steppe climate on the other side of the mountain. Okay? The side that receives the rain, so this side, is called the windward side. The windward side, and I want you to label this in your notes, the windward side is the side that receives the rain as part of a rain shadow effect. And the other side is called the leeward side. That side does not receive the rain as part of the rain shadow effect. The leeward side is the side opposite the prevailing wind, and the climate is arid or semi-arid. The Great Plains in the U.S. have this climate. Nevada is a desert. Utah and Nevada are very dry because of the rain shadow effect and the mountains, the coastal and the Cascade Mountains and the Sierra Nevada Mountains, blocking that rain from coming from the Pacific Ocean to that portion of the United States. Nevada, to a certain degree Colorado, although it's a little bit further west, or east rather. But Nevada, Utah, Arizona have a dry desert climate because of the rain shadow effect. All right, so that does it for our discussion of climate today. Tomorrow we're going to talk about, or in the next video, we're going to talk about how climate affects us. Okay, and you can also see here some of the Gulf Stream and the movement of water. And here's some cool climate region pictures. And there's a really cool graphic right there illustrating rainfall and sunshine and monthly temperature. Okay, hope you have a great day, and I will see you when you get back, and I'll see you guys later.